All right, today for the last section, we'll be covering a bunch of different lines, or a bunch of different theorems covering perpendicular lines. So remember, perpendicular lines are lines that are going to intersect at a right angle. So quite a few theorems today, so hopefully you have your composition book handy to write these down. Otherwise you'll have to get them later. Theorem 3.8, if two lines intersect to form a linear pair of congruent angles, so here 1 and 2 would be a linear pair and they're marked congruent, then that means your lines are perpendicular. Because if you think about it, a linear pair, your angles are going to add to 180. If they're congruent, well then they both have to be 90 degrees. Okay? And if we want to prove that, that would be part of our proof, saying that, well, 1 and 2 are a linear pair, so 1 and 2 are supplementary, they add to 180. Then you know 1 is equal to 2, so you could do some substitution, and then end up doing some division, and you would end up with BD is going to be perpendicular to line AC. Theorem 3.9, if two lines are perpendicular, so if we have two lines intersecting at a right angle, they're going to intersect and they're going to form 4 right angles. So 1, 2, 3, and angle 4 are all going to be 90. That has to do with the idea that, well, vertical angles are congruent. So if one's 90, the one vertical with it's 90. And then using linear pair postulate, knowing they add up to 180 tells you the other two are also 90. Theorem 3.10, if two sides of adjacent acute angles, so 3 and 4 are adjacent acute angles, if two sides are perpendicular, that means your angles are complementary. Complementary meaning they're going to add to 90 degrees. Theorem 3.11, if a transversal is perpendicular, so here's our transversal, line P, if it's perpendicular to one of two parallel lines, which we know they're parallel, well that means it's also going to be perpendicular to M. So if lines are parallel, you have a 90 down here, that means you have a 90 up here. You're perpendicular with M. And then finally, Theorem 3.12, in a plane, if two lines are perpendicular to the same line, then they're parallel. So here, if M and N are both perpendicular to line P, that means M and N are parallel to each other. So 5 theorems, make sure you get all those written down. Then, distance from a point to a line. Again, we're dealing with perpendicular lines today. Anytime you find a distance between a point and a line, that distance should always be perpendicular with your line. That's going to be the shortest distance. Rather than having, a point here to here or here to here, you want the one that's going to be perpendicular. We'll talk about that a little more coming up. So what theorem justifies the statement A is parallel to B? So here we got line A, line B, and we have line C. So you notice we got two 90s. So in other words, which theorem says if two lines are perpendicular to the same line, then they're parallel. So if you already wrote them down, see if you can figure out which one. The correct answer is that very last one we did, which is Theorem 3.12. Next one says find x. Well, most of you are probably just going to assume, oh, they add up to 90. Okay? Well, you're right. That's because these two angles are congruent, which means they're a linear pair, so these each are 90. If this is 90, then this angle's 90. So we can say 10x plus 12 plus 3x equals 90. So 13x plus 12 equals 90. So 13x is going to equal 78. And so x would be 6. All right, find the distance between parallel lines. Remember, distance always needs to be a perpendicular line. Well, we know slopes of perpendicular lines are opposite reciprocals. So if we look at these two lines, they have a slope of 1 over 2. So because they have a slope of 1 over 2, when we're finding our distance, we need the opposite reciprocal slope. So our slope needs to be -2. So what's going to happen is you're going to pick a point. Say this one. Now to find our distance, we got to use that slope of -2. So to the left, up 2 over 1. Up 2 over 1, up 2 over 1. So we need to find the distance between these 2 points. So that should tell you distance formula. So remember distance formula, we got x2 minus x1 squared plus y2 minus y1 squared. Let's get rid of all that. So ours, this x is -1, this x is 2. So -1 minus 2 squared plus y value of 6, y value of 0. So 6 minus 0. So -3 squared plus 6 squared. So square root of 9 plus 36, which is square root of 45, which if you do your factor tree, that ends up being 3 square root 5 is the distance. Okay, so again, to find distance between two lines, you got to find one that's perpendicular to those, and then find your 2 points and use distance formula. All right, find the measure of each numbered angle. We got 1, 2, 3, 4, and 5. So as I'm writing, be thinking about which or what the measures are of the angles. All right, angle 1. Well, angle 1 right here, we got to find. Well, we have a 90, and if we have 2 perpendicular lines, it's going to make 4 right angles. So all 4 of these are right angles. So to get angle 1, we would do 90 minus 34. So angle 1 would be 56 degrees. Angle 2 is pretty obvious. It's a right angle, so that would be 90 degrees. Angle 3 is vertical with this angle, so that would be 34 degrees. Angle 4, well, this one's 34. So 90 minus 50 minus 34 is going to give us 6 degrees. And angle 5, again, should be pretty obvious. That's 90 degrees. And just like that, there's your assignment. So make sure you copy it down right. You're doing all the problems you need to. This one jumps around quite a bit. Number 26, you don't have to justify your answer, but on the other ones I would like you to do so if it asks you to. Alrighty. Good luck with your assignment. If you have no idea what you just watched, I suggest watching it again and maybe put the phone away or turn the TV off. Some of you, I feel like, are watching the videos, but you're not really paying attention. So make sure when you're watching the videos, you're paying attention. You're trying to think about the examples and try to work them out on your own before you go ahead and see what the answers are. I think you'll do a lot better. And make sure when you're in class, you're actually using your time to work. The idea of this flipped classroom is so you have more class time to get help from me, not so you have more class time to screw around.